Picture this. You're planning the ultimate heist. The target? A planet worth $26.99 million. The prize? Enough diamonds to make every person on Earth a trillionaire. The only problem? This cosmic bank vault has the most extreme security system in the universe. 2,000-degree temperatures, crushing gravity, and a toxic, churning atmosphere. Today, we're planning the impossible heist to 55 Cancri E, and I'll show you exactly why this diamond planet is both the greatest treasure and the deadliest trap in space. But first, let me promise you something. By the end of this video, you'll discover why everything the media told you about the diamond planet might be wrong. And you'll learn about a shocking discovery from May 2024 that changes our entire understanding of this cosmic jewel. So buckle up. We're going on a journey to the most beautiful and most hostile world in the known universe. Let me start with a number that will melt your brain. $26.99 million. That's more money than has ever existed in human history. To put this in perspective, if you could somehow spend $1 million every second, it would take you longer than the age of the universe to spend it all. Welcome to 55 Cancri E, a world 41 light years from Earth, 8 times heavier than our planet, and according to some scientists, made almost entirely of diamond. But here's where it gets interesting. This isn't just any diamond. We're talking about a planet where the entire interior has been compressed into the most valuable substance on Earth. The surface? It might sparkle like the Hope diamond, but magnified to planetary scale. Now, you might be thinking, this sounds like science fiction. And honestly, I thought the same thing when I first heard about it. But the story of how we discovered this cosmic treasure chest is even more incredible than the planet itself. But here's the thing that will blow your mind. What if I told you that by the end of this video, you'll discover this entire diamond planet story might be built on a lie? Let's go back to 2004. Astronomer Barbara MacArthur is staring at data from the Hobby-Eberly telescope in Texas. She's looking at a star called 55 Cancri A, about 41 light years away. Nothing special, right? Just another sun-like star in the constellation Cancer. But MacArthur notices something that shouldn't be there. The star is wobbling. Tiny movements, almost imperceptible, but they're there, regular as clockwork, every 17 hours in 41 minutes. This wobble means one thing. There's a planet out there, orbiting so close to its star that its entire year lasts less than 18 hours. MacArthur has discovered what we now call 55 Cancri E. But here's the problem that would haunt scientists for years. All she can measure is the planet's mass, about 8 times heavier than Earth. She has no idea how big it is, what it's made of, or what it looks like. Imagine being a detective with only one clue: the weight of your suspect. You know they're heavy, but are they tall and thin, or short and incredibly dense? This mystery would take 7 more years to solve. Fast forward to 2011. The MOST Space Telescope catches something incredible. The planet actually passes in front of its star. This transit gives us the missing piece of the puzzle. Now we can measure its size, about twice Earth's radius. Do the math, and you get a density that makes scientists' jaws drop. This planet is incredibly heavy for its size, way too heavy to be made of rock and water like Earth. And that's when everything we thought we knew about planets got turned upside down. Then comes 2012. the year everything changed. Niku Madhusudan at Yale University is analyzing the chemical composition of the star 55 Cancri A. He discovers something that shouldn't be possible. This star has way too much carbon compared to oxygen. Now, this might sound boring, but it's actually revolutionary. Think of it like this. In our solar system, oxygen is the dominant player. That's why we have rocks made of silicon and oxygen, water made of hydrogen and oxygen. But in a carbon-rich system, it's like playing the same game with completely different rules. Madhusudan runs the numbers through his computer models. The results are mind-blowing. In a high-carbon environment, planets don't form from silicate rocks. They form from carbon compounds. And under the extreme pressure inside a planet 8 times Earth's mass, carbon gets squeezed into its most stable form, diamond. Madhusudan publishes his paper with a conclusion that breaks the internet. 55 Cancri E could be made of graphite and diamond rather than water and granite. The media goes absolutely crazy. Headlines scream about the diamond planet. Forbes calculates its value at $26.9 million. Suddenly, everyone wants to know about this cosmic treasure chest. But here's where our heist planning gets serious. What would this planet actually look like? Imagine flying toward 55 Cancri E in your spaceship. From a distance, you might expect to see something like a giant sparkling jewel floating in space. But the reality would be very different. First, you'd notice the planet is tidally locked. One side permanently faces its star, glowing white-hot like molten metal. The other side sits in eternal darkness, but still radiating heat like the inside of an oven. As you get closer, you'd see the surface isn't the clear, brilliant diamond you might expect. Under these extreme conditions, the diamond would be polycrystalline, opaque, probably black or gray from impurities. Think industrial diamond, not jewelry store diamond. But let's say you want to land anyway. You're here for the heist, right? Well, here's where our mission becomes a suicide mission. The moment you enter the atmosphere, your spacecraft starts screaming warnings. The gravity here is 2.3 times Earth's. If you weigh 150 pounds on Earth, you now weigh 345 pounds. Your bones start to ache. Your heart struggles to pump blood against the crushing force. But that's just the beginning of your problems. The atmospheric pressure is crushing, hundreds of times stronger than Earth's surface pressure. It's like being at the bottom of an ocean, but an ocean made of superheated gas trying to compress you into a pancake. And speaking of heat, the dayside temperature is over 2,000 degrees Celsius. That's 3,600 degrees Fahrenheit. Hot enough to melt copper. Hot enough to turn rocks into lava. Your heat shields are failing. Your instruments are frying. And you haven't even touched the surface yet. But let's say, somehow, you make it down. You step out of your spacecraft onto the surface of the diamond planet. What happens next? You have about 3 seconds before the heat kills you. But in those 3 seconds, you'd be standing on something incredible. The ground beneath your feet isn't soil or rock. It's compressed carbon, diamond, stretching down potentially thousands of kilometers into the planet's interior. You might try to chip off a sample, but this isn't jewelry store diamond. It's industrial diamond, harder than steel, and it's fused into the planetary structure under pressures we can barely imagine. Plus, there's another problem. The atmosphere might be toxic. In a carbon-rich world, chemical reactions create compounds like hydrogen cyanide. One breath and you're dead. So our heist is looking pretty impossible. But wait, it gets worse. Here's the dirty secret that will ruin your diamond dreams forever. Remember that $26.9 million price tag? If you somehow manage to mine this entire planet and bring all that diamond back to Earth, you wouldn't be rich. You'd be broke. Why? It's basic economics. Diamonds are only valuable because they're rare. Flood the market with a planet's worth of diamonds, and their value crashes to basically zero. You'd have the most expensive paperweights in the universe. But here's where our story takes the most dramatic turn yet. What if everything we just discussed is completely wrong? See, the diamond planet theory has always been controversial. Some scientists looked at the same data and came to different conclusions. They argue that 55 Cancri A might not be as carbon-rich as we thought. Maybe the planet is more like Earth than like a giant gemstone. For years, this remained one of astronomy's biggest debates. Team Diamond versus Team Rock. Both sides had evidence. Neither could prove their case definitively. Scientists were stuck. They had a mystery planet 41 light years away and no way to definitively solve it. And then came 2024, the year that changed everything. In May 2024, the James Webb Space Telescope turned its incredible instruments toward 55 Cancri E. JWST isn't just any telescope. It's the most powerful space observatory ever built, capable of analyzing the faint light from distant worlds in unprecedented detail. What JWST discovered shocked everyone, including the scientists who made the discovery. 55 Cancri E has an atmosphere, a substantial, active atmosphere. Now, this might not sound revolutionary, but it absolutely is. Scientists thought any atmosphere should have been stripped away long ago by the intense radiation from the nearby star. The fact that there's still an atmosphere means it's being constantly replenished. But replenished from where? The answer is mind-blowing. The atmosphere is being created by the planet itself. Gases are bubbling up from a vast ocean of molten rock covering the entire surface. This isn't a dead, static world. It's geologically active, dynamic, alive in a sense. The atmospheric composition? Carbon dioxide and carbon monoxide. Exactly what you'd expect from a carbon-rich world with active volcanism. This discovery doesn't prove or disprove the diamond interior, but it adds a crucial new layer to our understanding. 55 Cancri E isn't just a static chunk of compressed carbon. It's a complex, evolving world with active geology, atmospheric dynamics, and surface processes we're only beginning to understand. Think about it. We're looking at a planet where the surface is a global ocean of lava, constantly releasing gases into a thick, toxic atmosphere. The interior might be diamond, but the surface is pure hell. And here's the beautiful irony that changes everything. The planet's real value isn't in its potential diamonds. It's in what it teaches us about planetary formation, atmospheric science, and the incredible diversity of worlds that exist in our universe. 55 Cancri E is a natural laboratory for studying extreme conditions, pressures, and temperatures we can barely recreate on Earth.
Chemical processes that don't exist anywhere in our solar system. It's helping us understand how planets form in carbon-rich environments and how they evolve over billions of years. Every observation of this world expands our knowledge of what's possible in planetary science. It challenges our assumptions about habitability, atmospheric retention, and the chemical diversity of exoplanets. But let's zoom out for a moment. What does the existence of 55 Cancri e tell us about the universe? First, it shows us that planetary formation is way more diverse than we imagined. We used to think all rocky planets would be basically like Earth, Mars, or Venus. But 55 Cancri e proves that planets can form from completely different chemical recipes, creating worlds unlike anything in our solar system. Second, it demonstrates the incredible extremes that planets can survive. Temperatures that would vaporize most materials, pressures that would crush any known spacecraft, radiation levels that would sterilize any known life. Yet this world has existed for billions of years, maintaining its atmosphere and geological activity. Third, it hints at the vast diversity of exoplanets waiting to be discovered. If one star system can produce a diamond planet, what other exotic worlds are out there? Picture this: planets made of pure iron, where the entire surface is metallic. Worlds where it rains glass sideways at 5,000 miles per hour. Ocean planets covered in liquid diamond under crushing pressure. The possibilities are endless, and we're finding new ones every year. The story of 55 Cancri e also teaches us something profound about scientific discovery. The initial diamond planet hypothesis captured public imagination, but science doesn't stop at the first exciting result. It keeps investigating, questioning, and refining our understanding. The 2024 JWST observations are a perfect example. They didn't prove or disprove the diamond theory. Instead, they revealed that the reality is more complex and more interesting than either the diamond planet or rocky planet models predicted. This is how science works at its best. Each new observation adds another piece to the puzzle, bringing us closer to understanding these incredible worlds. And speaking of new observations, we're just getting started. JWST will continue studying 55 Cancri e, potentially revealing more details about its atmospheric composition, surface temperature variations, and internal structure. Future space telescopes will have even more powerful capabilities. We might eventually be able to create detailed maps of the planet's surface, track weather patterns in its atmosphere, and even determine the exact composition of its interior. But here's the most exciting part. 55 Cancri e isn't unique. As our planet hunting techniques improve, we're finding more and more exotic worlds. Super-Earths with diamond interiors, mini Neptunes with metallic hydrogen cores, planets where the very concept of weather gets redefined by physics we can barely comprehend. Each of these worlds expands our understanding of what's possible in the universe. They challenge our assumptions about planetary science and push the boundaries of our knowledge. So what's the ultimate lesson of the diamond planet? Beauty and hostility often go hand in hand in space. The most visually stunning worlds are frequently the most deadly. The most scientifically valuable planets are often the most impossible to visit. 55 Cancri e embodies this paradox perfectly.
It's potentially one of the most beautiful worlds imaginable, a planet that might literally sparkle like a jewel. But it's also one of the most hostile environments in the known universe. This teaches us something profound about exploration and discovery. Sometimes the greatest treasures aren't the ones we can touch or possess. They're the ones that expand our minds and deepen our understanding of the cosmos. The real value of 55 Cancri E isn't $26.9 million in diamonds. It's the priceless knowledge it gives us about planetary formation, atmospheric science, and the incredible diversity of worlds that exist beyond our solar system. Every time we study this planet, we learn something new about the universe. Every observation brings us closer to answering fundamental questions about how planets form, how they evolve, and what conditions might exist on other worlds. And who knows? The techniques we develop to study 55 Cancri E might eventually help us find and characterize planets that could harbor life. The atmospheric analysis methods pioneered on this hellish world might be the same tools we use to detect biosignatures on more hospitable planets. In a way, 55 Cancri E is like a cosmic Rosetta Stone, helping us decode the language of planetary science and atmospheric dynamics. It's teaching us to read the stories that distant worlds tell through their light. So the next time you look up at the night sky, remember this. Somewhere out there, 41 light years away, a planet made of diamond is spinning through space. Its surface glows with molten lava. Its atmosphere churns with toxic gases. Its interior might contain more compressed carbon than has ever existed on Earth. It's beautiful. It's deadly. It's scientifically priceless. And it's reminding us that the universe is stranger, more wonderful, and more diverse than we ever dared imagine. The diamond planet heist might be impossible, but the scientific treasures we've already stolen from this distant world are worth more than all the diamonds in the universe. If you enjoyed this journey to one of the most extreme worlds in space, hit that subscribe button. Next week, we're visiting an even stranger planet, one where it rains molten glass sideways at hurricane speeds. Trust me, you don't want to miss that cosmic nightmare. And let me know in the comments, which extreme exoplanet should we explore next? The universe is full of impossible worlds, and we're just getting started on our cosmic treasure hunt. Until next time, keep looking up. The universe has more surprises waiting for us than we could explore in 1,000 lifetimes.